In the last hyperbola video, I didn't get a chance to do some concrete examples, so I'll do that right now. So let's say I had the hyperbola y squared over 4 minus x squared over, I don't know, let me think of a good number. Let's say x squared over 9 is equal to 1. So the first thing to figure out about this hyperbola is what are its asymptotes. And once again, I always forget the formulas, and I just try to solve for y and see what happens when x approaches positive or negative infinity. So if you solve for y, you can add x squared over 9 to both sides, and you get y squared over 4 is equal to x squared over 9 plus 1. Now I can multiply 4 times both sides, and you get y squared is equal to 4 over 9 times x squared plus 4. Right? Distribute the 4. Take the positive and negative square root of both sides. Y is equal to the plus or minus square root of 4 over 9x squared plus 4. And you can't really simplify this anymore, but we can think about what does this approach as x approaches positive or negative infinity. So as x approaches plus or minus infinity, what does this roughly equal? What does this approximate? What does the graph get a lot closer to? Well, then y is approximately equal to just the square root of this term, because this becomes super huge, and relative to this term, this starts to matter less and less and less. And that's why we get closer and closer to the asymptotes. Because when this number is like a trillion or a Google, then this number is almost insignificant. When you take the square root, you're pretty much taking the square root of this, and you'll just be a little bit above the graph because you have this extra plus 4 there. So as you approach positive or negative infinity, this equation is approximately equal to the plus or minus square root of 4 over 9 x squared. And so that is, so y would be approximately equal to the plus or minus. We can take the square root of this. Plus or minus square root of 4/9 is 2 over 3, right? Square root of 4 over square root of 9 times x. So these are the asymptotes. There's two lines here. There's y is equal to 2/3 x, and then there's y is equal to minus 2/3 x. So let's draw those two lines. Let me draw my axes. So let's make that my y-axis. Let's make that the x-axis. Let me switch some colors just to make things interesting. So let me draw the first one. See, y is equal to 2/3 x. So you rise 2 for every 3 that you run. So let me draw that. So if this is 1, 2, 3, 1, 2. So that would be a point on the line. And let me draw the line now. It should go through the origin. Oh, no, that's not it. Let me draw it like this. This way I can make sure it goes to the origin. So it's going to go through like that. And then I can go from here and then go like that. So that's one asymptote. And the other asymptote is y is going to be equal to minus 2/3 x, right? Because it's plus or minus 2/3 x. So minus 2/3 x, you go down 2 for every 3 that you go out. So that point will show up. Let's see if I do 1, 2. So you go down 2 for every 3 that you go out. So it'll go there. So if I draw that asymptote, it'll look something like